Next, NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again after months of spouting gibberish.
For over 45 years, NASA's Voyager 1 spacecraft has been traveling farther from Earth than any other probe, providing us with astonishing glimpses of the far reaches of our solar system and beyond. Recently, Voyager 1 has sent back some puzzling signals that have scientists scratching their heads. What could these mysterious messages mean? Could they be a sign of something extraordinary or just a glitch? With Voyager 1's incredible voyage through space and its recent unexpected data, what new secrets might we discover about the universe? Well, to know all about this, you have to stay tuned till the end. Voyager 1 was launched on September 5, 1977, from the Kennedy Space Center in Florida, following closely behind its twin, Voyager 2. Both spacecraft were part of NASA's Grand Tour mission, designed to take advantage of a rare alignment of the outer planets that occurs only once every 176 years. The primary objective was to explore Jupiter, Saturn, Uranus, and Neptune, providing a detailed look at these distant worlds and their moons. Its mission trajectory was set to fly by Jupiter and Saturn, while Voyager 2's path would take it past Jupiter, Saturn, Uranus, and Neptune. Each spacecraft was equipped with a suite of scientific instruments to study magnetic fields, cosmic rays, plasma waves, and planetary atmospheres. In March 1979, Voyager 1 made its closest approach to Jupiter, about 349 million kilometers from Earth. This encounter provided the first detailed images of the gas giant and its complex system. It captured over 20,000 photographs of Jupiter and of its moons during its flyby. One of the most significant discoveries was the identification of Jupiter's faint ring system. While not as prominent as Saturn's rings, Jupiter's rings were a crucial find, as they provided new insights into the formation and dynamics of planetary ring systems. Voyager 1 also uncovered two new moons, Thebe and Metis, expanding our knowledge of Jupiter's satellite system. The spacecraft's observations revealed the massive Great Red Spot, a persistent storm system larger than Earth, and provided the first close-up images of Jupiter's cloud bands and atmospheric dynamics. The data collected by it helped scientists understand the planet's complex weather patterns and magnetic field. Voyager 1 continued its journey to Saturn, arriving in November 1980. The spacecraft's approach provided unprecedented views of Saturn's majestic rings, which are composed of ice and rock particles. Voyager 1's imaging of the rings allowed scientists to study their structure and composition in detail. The spacecraft also discovered new moons around Saturn, including Mimas, Enceladus, Tethys, and Rhea. These moons exhibited a range of geological features, from icy surfaces to potential subsurface oceans. Voyager 1's observations of Enceladus revealed geysers erupting from its surface, hinting at a subsurface ocean and making it a prime candidate for further exploration. Voyager 1's Saturn flyby also included a gravity assist maneuver, which boosted its velocity and directed it toward its next destination. The spacecraft's close encounter with Saturn allowed it to collect valuable data on the planet's magnetic field, atmospheric composition, and ring structure. After its encounter with Saturn, Voyager 1 transitioned to the interstellar mission phase. In 1990, Voyager 1 became the first spacecraft to enter into interstellar space, leaving the bubble of particles and magnetic fields known as the heliosphere that surrounds our solar system. This milestone marked a new chapter in the mission, allowing Voyager 1 to explore the space between stars. One of the most iconic moments in the interstellar mission was the pale blue dot photograph taken on February 14, 1990. From a distance of about 6 billion kilometers, Voyager 1 captured Earth as a tiny speck against the vastness of space. This image, famously described by astronomer Carl Sagan as a mote of dust suspended in sunbeam, offered a humbling perspective on our place in the universe. The interstellar mission allowed it to continue its journey and gather data on the Helios sheath, the outermost layer of the heliosphere, and the boundary between the solar wind and interstellar space. The spacecraft provided insights into the structure of the heliosphere and the cosmic rays that permeate the space between stars. Voyager 1's mission has produced a wealth of scientific data that has transformed our understanding of the outer solar system and interstellar space. The spacecraft's findings have reshaped our knowledge of planetary rings, moons, and the structure of the heliosphere. It has also contributed to the field of cosmic ray research. By measuring the intensity and composition of cosmic rays, the spacecraft has provided valuable information about the radiation environment in interstellar space. This data is crucial for understanding the effects of cosmic rays on spacecraft, astronauts, and planetary atmospheres. In recent months, Voyager 1 has transmitted data that has raised concerns and sparked curiosity among scientists. The spacecraft has been sending signals that suggest it is struggling with its orientation and navigation systems. These anomalies have led to speculations about the potential causes and implications of the data. Initial analysis revealed that the Attitude Articulation and Control System, or AACS, which controls Voyager 1's orientation, had switched to a backup computer that had been inactive for years. This unexpected change in the AACS's operations resulted in distorted data transmissions and a loss of coherence in the spacecraft signals. NASA engineers intervened by instructing the AACS to revert to the primary computer, which restored normal data transmission. However, the reason for the switch to the faulty computer remains unclear. Scientists are investigating the possibility of a command error or a malfunction in the onboard systems. The anomalies have prompted a thorough review of Voyager 1 systems and operations. NASA engineers are conducting a detailed analysis of the spacecraft's memory and diagnostic data to identify the root cause of the issue. The findings from this investigation will help ensure the continued operation of Voyager 1 and address any potential issues that may arise in the future. Voyager 1's mission has exposed the spacecraft to the harsh conditions of space, including extreme temperatures, cosmic radiation, and micrometeoroids. These factors can impact the spacecraft's performance and reliability over time. Spacecraft operating in the outer reaches of the solar system experience temperatures as low as minus 270 degrees Celsius. These extreme cold conditions can affect the operation of electronic components and scientific instruments. To mitigate these effects, Voyager 1 is equipped with thermal blankets and heaters to help regulate its temperature. Cosmic radiation poses another challenge for spacecraft. High-energy particles from distant stars and galaxies can penetrate spacecraft structures and interfere with electronic systems. Voyager 1's instruments are designed to detect and measure cosmic radiation, providing valuable data on the radiation environment in interstellar space. Micrometeoroids and space debris also pose a risk to spacecraft operating in deep space. These tiny particles can impact the spacecraft's surface at high velocities, potentially causing damage to its instruments and systems. Voyager 1's engineering team has designed the spacecraft to withstand impacts from micrometeoroids and minimize their effects on its performance. The recent anomalies in Voyager 1's data have led to a range of theories and speculations. Some scientists have proposed that the spacecraft might have encountered interstellar objects or rogue planets, which could be influencing its sensors and communications. Rogue planets are celestial bodies that do not orbit any star and wander freely through space. The detection of such objects could provide valuable insights into planetary formation and dynamics. So, do you admire this spacecraft, or do you have any others in your list of favorites? Let us know in the comment section below, and for more such amazing videos, make sure you subscribe to our channel. Thanks for watching!